Thank you very much for those kind words. And good afternoon. It's great to see so many friends here. It's always good to be back in Greece. Um, what I'd like to do this afternoon is just spend a little bit of time talking about some of the things that I have seen. I have been kind of working this exciting and developing story for the last 3 years. And I wanted to use this opportunity to kind of share some of my thoughts relative to kind of where we are, kind of where we're going. And obviously, I'll be speaking from my background, which is really, classification and really focusing on a little bit of the regulatory framework, a little bit of the relative to the kind of the safety issue and some unintended safety consequences and how we're dealing with them and how this whole ball is moving forward. So let me just start by saying, I think you've heard already, but today we are witnessing the convergence of essentially innovation, investment, and regulations in commercial nuclear technology. The momentum is building, and I think that's the exciting part. And the conditions for progress are rapidly developing, and we'll talk a little bit about that. Across the maritime and energy sectors, the pieces are actually starting to come together between advanced reactor technologies, the kinetics of what's actually in the reactor, robust class rules. We now do have class rules that begin to cover some of the topics we've talked about. We're looking now at purpose-built testing facilities and processes specifically for marinization. We're looking at an evolving regulatory framework. Obviously, last week you heard, and we'll talk a little bit about this. I'll spend a little bit more time about the emergence of nuclear corridors. Those become very, very important. A lot of work has been done on feasibility studies. And that's actually quite important because the continued development of feasibility studies really kind of in some cases, and we'll talk about kind of the sequence of these, we'll move into concept studies. Eventually, they'll move into prototypes. But there's quite a lot going on in that area. And obviously, a very growing appetite for public-private partnerships. You've heard a little bit about the economics. I will tell you, the economic models are very promising. And if you really got down to it and looked at it, and even quite frankly, factored in the residual value of the reactors over a lifetime, the models do become quite interesting. If you look also at, you look at the cost of compliance, the cost of operations, and how all that begins to kind of offset the initial front-end CapEx costs. But the models are promising, and that's interesting to see, and that is actually triggering, obviously, a greater investment interest because that is growing. And so you're beginning to see that a lot of things now, as they start to move together, that maybe 3 or 4 years ago were uncertain. Now they're beginning to come into focus. So I believe that this convergence marks a turning point. I think nuclear energy, in my opinion, is no longer a distant possibility for maritime applications. I think it is emerging now as a legitimate, practical, and scalable solution for a wide range of strategic uses. And we'll talk about kind of what that commercial pathway is and what I believe the sequence of applications will be as we move forward. Nuclear energy is stepping forward as a credible long-term solution, not simply because of its potential to reduce emissions, but because it offers unmatched energy density, reliability, and strategic independence. I think you've heard a lot about that today. And quite frankly, not only strategic energy independence, but national energy security together. So the two kind of come together, and nuclear begins to become the catalyst for that. And in maritime applications, we do see a clear roadmap. This journey, I believe, begins with shoreside applications, powering ports and producing hydrogen. And then it moves offshore to floating data centers, synthetic fuel platforms, desalination systems, and ultimately domestic nuclear-powered commercial vessels, and then to the global fleet. So you can begin to see, and we'll talk a little bit about that, kind of what I believe is the kind of a practical sequence as we begin to look at nuclear power and marinizing nuclear power. Commercial nuclear corridors will be, I think, absolutely central to enabling a move into propulsion. Purpose-built ecosystems, which these really represent, integrate infrastructure, regulation, policy, innovation, and quite frankly, really begin to explore and test and probe the ship-to-shore interfaces and shoreside readiness. And they're not going to be just test beds. I actually believe that these are going to be strategic enablers for us going forward, and to some extent, strategic accelerators. But applications based on maritime assets, I think, will begin with floating power barges, because they will be more straightforward to design, build, and operate, because these types of applications will be based in a single location at a time. The regulatory approval process required around this, dealing with safety, security, and non-proliferation safeguards, is going to be easier to achieve compared to vessels operating across multiple geographies and jurisdictions. And I think I've seen some of that already here. Floating nuclear powered data centers are actually a good example of this opportunity. These platforms sit at the intersection of three strategic imperatives. They've been outlined essentially in the recent U.S. executive orders, but quite frankly, they have applications globally, tying maritime energy and artificial intelligence. They offer unmatched uptime, zero emission energy, and the ability to support high-density AI workloads offshore, where cooling, security, and energy availability are optimized. By 2050, we actually anticipate that floating nuclear-powered data centers could capture up to 10% of the global market. And in the U.S. alone, this would mean 9 total facilities. And while the market cap is still evolving, and this story is still working its way through, projections estimate that the total data center market volume will reach $212 billion in 2029. So as you can see, this is not just a niche opportunity, it's actually a strategic growth vector for the application of nuclear technology to the maritime space. At ABS, our goal and where we come from is pretty clear. Our goal is to ensure that this type of transformative technology develops with the highest safety standards while positioning the maritime industry to capitalize on its game-changing potential. We've been the industry's nuclear pioneer since 1962. We supported the NS Savannah, and we published the first nuclear ship requirements. Today, we're bridging that gap between the outdated 1960s regulation and modern reactor technologies. Our recently published Floating Nuclear Power Plant Guide is amongst the most significant Western advancements in nuclear maritime regulations in decades, modernizing obsolete standards with contemporary IAEA safety concepts. It does provide a robust framework for safety, resilience, and operational integrity. So you can see from where we sit, from an ABS point of view, we have really completely bought into this, and we're spending quite a lot of our activities and our initiatives really now trying to create that right regulatory and safety framework going forward. We're doing a lot of joint development work, and through our joint development projects with Core Power and Athlos, I think you'll hear more about that. We're preparing an FNPP deployment here in the Mediterranean. I think our Athens-based Global Ship Systems Center here is working very closely to develop essentially a pestle set of studies evaluating political, economic, social, technological, legal, and environmental factors to help begin to identify viable sites across islands, ports, and coastal communities where some of this technology now will really be able to make sense and we'll be able to take advantage of it. Floating nuclear power has the potential to contribute to other significant global challenges. By 2050, global demand will require 7,266 million metric tons of water per day to meet desalination needs. We have been working on several concepts, but This basically is going to require 600, almost 700 new desalination facilities. The global desalination market is projected to reach $35.5 billion by 2032. Nuclear-powered floating desalination platforms offer very much a scalable, zero-emission solution to this challenge, especially for island nations and coastal regions facing water stress. So you can begin to see kind of from where we sit, kind of the beginning of what we think is a systematic sequence. Similarly, the maritime sector will require 46 million metric tons of hydrogen and 183 million metric tons of ammonia by 2050 to meet the decarbonization goals, I think, that have been explained here earlier. With projected energy prices ranging from 107 megawatts per hour to 145 megawatts per hour for hydrogen and 67 megawatts per hour to 114 megawatts per hour for ammonia, nuclear offers a stable, high output energy source to support green fuel development at scale. Propulsion of commercial vessels, as we move forward using advanced nuclear technology, I think is going to be more of a regulatory and public acceptance challenge than a technical challenge. Vessels that are powered by small modular reactors are likely to operate initially on narrowly defined corridors between two countries with favorable acceptance of nuclear power and with mature regulatory oversight agencies. And we see this example kind of unfolding right now within, in front of our eyes between the last week's declared U.S.-UK nuclear corridor. Very similar to a green corridor concept for those that are familiar with that. Commercial nuclear corridors can be the foundational infrastructure we need to unlock the full potential of nuclear technology and commercial shipping, enabling safe deployment, regulatory alignment, and scalable integration across energy, data, and logistics ecosystems. Commercial nuclear corridors provide a self-contained infrastructure and vessel support system with a commercial trade and thereby overcome one of the key obstacles to the adoption and spread of the technology, which is uncertainty. Nuclear corridors are going to allow us to better understand, study, assess, and quantify the impacts and the risks associated with how do we develop multiple safety layers? How do we understand the extent of emergency planning zones? This actually is an important concept. The reason why small modular reactors, we talk about small modular reactors in the maritime space, because if you take a traditional pressurized water reactor and you put it on a ship and you put the ship in the port, the actual safety zone extends way past the ship and it's into the port. You cannot ensure that. What this new, what small modular reactors do, this new nuclear technology does, it confines the emergency planning zone to the ship. That's actually, at the end of the day, what allows us to have a lot of these discussions because it becomes insurable. But nuclear corridors will also help us understand shoreside readiness in the form of handling, berthing, supply chain, support and logistics, and probably most important, personnel training, dealing with everything from emergency response to emergency management. So these become very important. They're essentially become live laboratories for us to really bring a lot of things together. They will allow major stakeholders to collaborate, share knowledge, de-risk investments, and create the necessary infrastructure in the most strategic location. We are now at ABS going to be beginning to work with the U.S. government on developing essentially playbooks for nuclear corridors, very similar to what we did with green corridors going forward. Ultimately, this offers policymakers an opportunity to create an enabling ecosystem with targeted, fit-for-purpose regulatory measures, financial incentives, and most importantly, safety regulations. And as these develop, they will generate, I believe, strong demand signals to nations and ports, vessel operators, shipyards, and equipment manufacturers that catalyze the investment. We're not waiting for the nuclear future at ABS. We are actively building it through practical research, strategic partnerships, and proactive standard development. We've issued multiple approvals in principle already for 17,000 TEU container ships being developed at Hyundai, as well as different types of other vessels. We actually have a feasibility study and approval in principle for an LNG-powered, nuclear-powered LNG vessel, as well as we've looked at the application to various other types of ships like Suezmaxes. So there's a lot going on. We at ABS are working very closely with the U.S. Department of Energy. They are funding research in the area of testing and looking at different types of projects that could eventually lead to prototype demonstrations. So there's a lot going on. And I think the exciting part here is that for the first time, I think I can see in my own career, things are really now beginning to kind of, based on different driving forces, are really beginning to come together. Our work, I think, at ABS provides the critical bridge between essentially historical innovation and experience and modern innovation and technology. We are spending a lot of time beginning to shape standards, validate the technologies, and I think begin to prepare the industry for deployment as the economics continue to align. And like I said, I think the timing is right. I think the combination of penalties for carbon emissions, we'll know more about that in the next month or two, certainly in the next 14 months, incentives for investing in emission-free technologies and incentives for revitalizing, expanding shipbuilding in allied nations begin to offer a favorable calculus for maritime applications of advanced nuclear technology. In the U.S. alone, if you really deep dive and look at some of the legislation, the tax credits favoring nuclear power applications from recent legislation and pending legislation on shipbuilding tax credits and other incentives has the potential to shift the economics decisively by the time small modular reactors are ready for maritime deployment. So as you can see, this is not just about power. It's really about positioning the maritime industry to lead in a future defined by energy security, digital resilience, and environmental stewardship. I think the time to begin developing commercial corridors is not in the future, it is today. And I welcome the announcement last week. And I think that last week's landmark agreement between the U.S. and the United Kingdom marks a pivotal moment because it does essentially signal a commitment between two nations to accelerate the development of civil maritime nuclear power, including the potential establishment of a dedicated shipping corridor between two countries. It also signals a shared intent to shape international standards and strengthen energy resilience across strategic sectors. I think this is more than diplomacy. I think it's a signal to the industry that the conditions for nuclear maritime innovation are aligning. And with policy momentum, economic incentives, and technological readiness beginning to converge, the foundation for commercial nuclear shipping is being laid. The corridors that we do build today will define the energy, data, and environmental resilience of tomorrow. So let's begin. Thank you very much.